So trig, we're in 13.2. 13.2 is going to be about a thing called arithmetic sequences. I dropped that name on you in 13.1. Some of the sequences we did in 13.1 were arithmetic. So what's going on today? Every sequence is an arithmetic sequence, and what that means is they have a common difference, meaning they're going to add repeatedly the same number over and over and over and over again. Like for this one, we're adding 2, adding 2, adding 2, adding 2. The difference, the common difference, is 2. Some of the homework, I think one of the questions they'll ask you is something like just find the difference. So if your job is find the difference is 2. If we go to attack this one, the difference is 4. If we go to attack this thing, the difference would be 3. That's not usually all they ask, but sometimes they'll ask you just what's the difference. And so the difference is that common number that got added repeatedly. More often what they're going to ask you to do is find the general term, either because that's all they want or because they want you to use the general term to do some sort of math. So here's how we can find the general term. If you like the creative way we were doing 13.1, those skills still apply. But if you want to just blindly follow a pattern and memorize a rule, there's a rule that will take you there every time, and you don't have to do any really creative thinking on these. So the general term is always going to come by taking the first term plus the letter n minus 1 in parentheses times the difference. If you just blindly follow that pattern and stick in the right numbers in the right slots, you're going to get every general term right just fine. So for this one, if I want to follow this pattern, I just need the first term, which is 3, plus, put in parentheses n minus 1, times the difference. The difference is the 2. Every time this is jumping 2, so difference would be 2. If we set that up, that is a correct general term. It's going to be preferred by the math and algebra community that you simplify this. So the way you'd simplify this, you'd want to distribute. So here if we distribute, we'd have 2n minus 2. The 2n will live on. The minus 2 part will get combined with the add 3 part and be a plus 1 total. If you want to check and make sure you did the right thing, if you plug in 1, you'll get out the first term. If you plug in 2, you get out the second term. Plugging in 3, plugging in 4 would get you the third, fourth terms, etc. and so forth. So checking is always a good idea. But that's the scheme. Every problem will be about the same. So I'll do one more just to make sure we're established. But for this one, we would take the first term, which is the 6, plus, stick in parentheses n minus 1 every time, and that's going to want to multiply the difference. The difference was 4s, because every time that's hopping up 4. And then we look to distribute and such. So if we distribute, I have 4n minus 4. The 4n is locked, but the minus 4 can combine with the add 6 to have a net there of plus 2. So that's general terms. Sometimes the problems will ask you to go one step beyond that, but you'll still need the general term to do that. So if you're asked to find the 52nd term of this, I doubt if you'd really have the patience to add 3 on a lot more times and get to the 52nd term. That would be pretty annoying. So the best way to find the 52nd term of this is to work through the general term. The general term for this, we'd want to go 4 plus, I'm going to lower this because I think I might be extending a little bit low. We go 4 plus n minus 1 wants to distribute a 3. If we clean this up, we get 3n plus 1. So if we can figure out the general term, now we have the ability to do anything they ask of us. If they want the 52nd term, you just have to plug 52 in for n. Take 3 times 52 is 156. Add the 1. Eventually we'd end up getting 157 as the 52nd term of this sequence way down the line somewhere. Another thing they may ask you to do is the opposite. So we just used the general term a second ago. If we were given a position of a certain term, figure out what the number is. Like we figured out, the 52nd term would be 157. They could ask you, keep going, and eventually, long after 157, you'll run into a 307. And you'll no longer be looking at the 52nd term. You know, where are you in the list? So I'll recopy the general term over here. AN, we just found a second ago at 3n plus 1, but the camera doesn't show it anymore. So a second ago, we just took the 52 position to figure out that 157 would be the number. What we're going to do now is take 307 and plug it in, but not here. We'll take 307, which is going to eventually show up as a number in the list, to equal 3n plus 1. So if they tell you the position number, 52nd term, put that in for n. But if they tell you eventually one of the numbers in the list will be 307, that's representing a number in your list. So if 307 equals this, then it's algebra 1 time. Do some opposites. Subtract the 1 to get the 306, divide by 3, we'd be in the 102nd position. If we made a list of terms 102 numbers long, that last number we write would be 307 down the line. Another way they'll play around with general terms is not tell you the first one, but give you some numbers somewhere from the middle. So we can work at this and still get it figured out. They might tell you the 7th term is something. They might tell you the 12th term is something else. So what you're going to have to do is figure out how much space there is in two senses between these terms. From the 7th to the 12th, there's 5 terms worth of difference. 7 subtracted from 12, there's 5, a gap of 5 numbers, 5 jumps being made. You can go from 79 to 139, hop, 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 5 hops would get you covering that distance. You'd also want to subtract these numbers to figure out there's a 60 difference total. As we progress from 79 to 139, think number line spaces, we're covering 60 number line spaces in 5 terms worth of leaping. So to figure out what the difference is for each leap, take the 60 total difference that we have from subtracting those, divide by the 5 terms that we got of difference for subtracting those, and each jump would be 12. You would jump from 79 to 91, 103, 115, 127, 139. 139 would be created from the 5th jump you made. If you want to check that, just add 12s, use your fingers. So what we're trying to do is figure out a general term. The general term is going to need to be the first one, which we don't know yet, plus n minus 1 always, and we've got a difference of 12 right now. To figure out what the first term is, we're going to have to work our way back in time. So this was moving forward 5 terms. Each difference was 12, so that caused this to go up by 60. We're trying to backtrack, so we're going to have to subtract our way down from 79. From the 7th term back to the 1st, we need to go down 6 terms worth of space. But each term continues to be worth 12. 6 of these 12s, 6 times 12 is 72. We need to go down 72 numbers from 79. That tells us the first term would be 7. And then if we distribute and work this out, distributing is 12n minus 12. Minus 12 combined with an add 7 would be a total of minus 5. Another thing they're going to ask you to do is to find what's called arithmetic means. If they're asking you to find 3 arithmetic means between 1 and 13, what that means is they want you to build a list with 1, empty, 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 and then 13. They want 3 empty spaces in the middle, that's the 3 arithmetic means, and we have to figure out what these numbers are if we would hop equally each time. If they go simple on you, you could just use trial and error. If they stick to whole numbers, that wouldn't take you long. You could just try to see, like maybe they're adding 2, 3, 5, 7, nope. Maybe they're adding 3. So you jump to 4, 7, 10, 13, yep, add 3. But you can't count on them to do whole numbers all the time. Because if they were adding 2.76 5, it would take you a long time, trial and error, to get those numbers figured out. So here's a math way that you can figure it out, even if they go decimals, fractions, whatever, is recognize that we need to make 1, 2, 3, 4 jumps are being made. So 1's going to jump, then jump, then jump, then jump. There's 4 jumps to be made there as we make those leaps along the line. We need to recognize that from 1 to 13, if we subtract, there's 12 total spaces to be covered. So subtract first and last number, whatever that gets us. However many arithmetic means they say, the jump count will always be 1 more, because they're giving you the final destination of the final jump. You're trying to get 3 numbers figured out, the 4th landing spot is there. So we're going to subtract the numbers from 12, 4 jumps, divide, and that would tell us each jump was 3, and then just do what we did with trial and error. This would be 4, 7, 10, because I'm just adding 3 every time, and that would land on 13. These are the numbers that they're seeking as the 3 arithmetic means. The last thing they'll ask you to do is find the sums of some arithmetic sequences. There's 2 formulas you could use. To find the sum, one formula, if you know the first and last terms, you can do the first term plus the last term in parentheses. The amount of terms divided by 2 gets multiplied with that. Second formula, if you don't know the last term, but you know the difference, you can go twice the first term plus the amount of terms minus 1 has to multiply the difference. That all has to be figured out first, and then multiplied by the amount of terms divided by 2. So again, anything up there that says an n, that's the amount of numbers you're adding. Anything that says a1, that's the first term. If it says an, that's the last term. And if it says d, that's the difference. So this is a question with a famous story from math about a guy named Gauss. I'll tell the story after I do the math. It says, find the sum of the first 100 natural numbers. So natural numbers are the same as counting numbers. Counting numbers start with 1, 1, 2, 3, 4, those kind of things. So when I say find the sum of the first 100 natural numbers, I'm talking about 1, 2, 3, 4, up to 100. So in this circumstance, you know the first term is 1. You know the last term is 100. You know there are 100 of them. I would use this formula because it's a less scary formula. You could use this one because you do know the first, you do know there's 100 of them. You do know 100 minus 1 is 99. You do know the difference is 1. You could use that formula, but I don't think I would. I would use that top one. I'd go the 100 divided by 2 is 50. And then I'd go first plus last. 1 plus 100 is 101. Map that up is 50-50. So the story from history, Gauss is a famous mathematician. Way back days, I don't know, 1700, something like that. I'm making that date up, but it's back there a ways. So reportedly, he was a pretty young whippersnapper genius that drove his math teachers a little crazy because they just couldn't keep the kid busy. I mean, he's like this math genius. So at some point, the teacher said, okay, Gauss, get out of my hair. I want you to go and just go add up all the numbers from 1 to 100, come back when you have the answer. And Gauss said, 8-year-old Gauss, something like that, said, okay, teacher lady, it's 5,050. And the teacher lady was like, you have got to be kidding me. It was like almost instantaneous. I don't necessarily think Gauss created this formula, but he figured out the idea behind this formula almost instantly and added the numbers almost instantly by recognizing if you add up 1, 2, 3, 4, etc., etc., etc. for a while, 97, 98, 99, 100, like you'd have these numbers in a big loop that I'm not patient enough to add, or to write them all in a list. But the littlest number partnered with the bigger number adds to 100. Second from the beginning and second from the end, if you add that, adds to 101. The second one in and the second one from the back adds the 101. The third from each end add the 101. The fourth from each end add the 101. He pretty much instantly figured out that there were going to be a group of numbers that would add to 101. And if we're adding 100 numbers, 2 by 2 by 2, like Noah's Ark, there's 50 pairs of 101s. He figured out 5,050 like light speed. Now that's like a 300-year-old, 400-year-old, I don't know how many year old story that is, so that might be exaggerated over time, but that's like a little bit of math trivia story for you. The sum of the first 78 of this thing. Well, we know the first term, but we do not know the 78th term. We could figure out the 78th term if you insisted on doing it, but it'd be a fair amount of work. A few minutes ago we figured out the 52nd term of something was 157. If you wanted to jump through all of those hoops again, you could figure out the 78th term of that, but that feels like a lot of work. If you know the first, and you can figure out here the difference is 3 pretty quickly, that it's jumping by 3, I would just use this formula instead. We'd still go n over 2, so this time the n is 78. There's 78 items, so 78 items divided by 2 is 39. Then we'd want to go twice the first, 2 times 2 from the first is 4, plus n minus 1 would be 78 minus 1, so 77 times a difference of 3. We're looking to go there, multiply it out, calculator is your friend. This would be 231, 4 more is 235. 235 times 39. I'm going to say 9165. Probably. I have a paper, let me see. Yeah, 9165. That's true. For those of you in the home audience wondering how did he do that, I did 235 times 40 and figured that was close, but a little too high. So 235 times 40, that's like 235 times 4, which is this, which maybe that's amazing too, I don't know. But 235 times 40 is extra 0. I only wanted 39 of those, so I took like 235 back off, and it's 9165. But I'm no Gauss, but I'm doing okay for myself. The final way they can present these questions to you would be to go something in sigma notation. I'll turn the camera a little bit that way. We're going to have our choice here of what we want to do. So we don't know much of anything. So if we want to run this formula, either formula, we need to know the first term. So to know the first term, just put in the lowest number on the list. Put in the 1. 9 times 1 minus 4, that's 5. We need to know the first term regardless of what formula we pick. Personally, I would go ahead and use the formula where we know the last term. Okay, we're going as high as 47, so the last term is 47. 47th term, we could just plug 47 into this. So 9 times 47 is 423, yeah. Take 423 minus 4 would be 419. If you like that formula, we now go 47 over 2, because the total amount, there's 47 terms here from 1 to 47. And then we go first plus last. So we would need 23 and a half times 424. That doesn't sound like fun. Alternative plan, if you wanted to go with the other formula, we could go figure out the second term. Okay, the second term, 9 times 2 is 18, minus 4 is 14. If the first term's 5 and the second term's 14, the difference must be 9. So if you want to run this other formula, the lower one, we'd still go 47 over 2. we go 2 times the first one. So 2 times the first one's 10, plus n minus 1 is 47 minus 1 is 46, times the difference we had was 9. If you do the math on this, it should still land you on that same 424. You'd end up doing the 424 times all that stuff. 2 into this is 212. 212 times 47. I just don't want to. I'm not in the mood. Could I? I don't know. Maybe. I don't want to. But 212 times 47, I'm going to say 9964. 424 times 23 and a half. Same sort of result. That's all a bunch of stuff there, 13.2. So homework off of this, we're going to skip the multiples of 3. So 3, 6, 9, 12, skip them, skip them, skip them. We're going to work the 36. 564, working the 36. Arithmetic sequences, they have a common difference. By the time you work to the test, you for sure would want to have this an equals first plus n minus 1 times difference in your mind for general term finding. And for sure, the sum formulas, you'd want to jam both of those into your brain too somewhere, because you sure don't want to be adding up like 47 numbers. That's not good. That's it.